Hello, everybody. My name is Roberto Pereira. I'm a researcher here at CTC in Sustainable AI. I am one of the organizers of the LEAP special sessions, and today I'd like to give a brief of an introduction on our paper called Self-Supervised Learning at the Edge, the Cost of Labeling. So let me start by more or less stating the obvious, that is that self-supervised learning has enabled to learn rich representations from large unlabeled datasets. And this, of course, has real applications in large language models or visual transformers. Now, the problem is that to learn those self-supervised learning solutions, it typically leads to a large computational cost, make it really challenging to learn in resource-constrained devices like edge devices. And what people have started doing was basically to reduce the amount of data that you are using to either learn those or to fine-tune those solutions in edge device, but also introduce partial labels. So the idea is to basically boost the performance of the model by introducing labeling. So our main contributions in this particular work is to first build a framework to measure the total energy of learning, also including the labeling and the training. We do this in real world hardware, and also we consider the empirical cost of labeling. So by the end of this talk, and also when you visit us in our poster, you will be understanding how to balance the data labeling and the energy used in real world AI deployments. So the typical scenario that we are considering is an edge device that is generating continuous amount of data. And for instance, a use case is image classification in Earth observation, where you typically have a satellite that is screening over the entire Earth. It then selects a patch, which represents a large amount of area on Earth. This area is then subdivided into other ones, which then needs to be classified and, I don't know, into areas that are green areas, areas that are representing buildings, areas that are representing roads, and so on and so forth. For the method that we are considering, we're basically considering four: baseline cross entropy, supervised learning, self-supervised learning, seem clear, semi-supervised learning, and unsupervised contrastive learning. Then, as I mentioned to you before, for energy, we are considering the real hardware energy measurement, which is basically the sum of the CPU, GPU, and memory consumption. Then we are considering for labeling empirical labeling, which basically consider that you're using a standard laptop, and then you count for how long you are taking to label one single sample, and then you can more or less estimate what is the energy that is consumed through the entire data set for labeling these data samples. Then, of course, as a sum, you have the total energy, that's the total of labeling plus training. In order to simulate different edge device, we basically use different data regimes. So for instance, if you have 20% of the data, which is here in blue, you're basically considering device which is like in far edge device. So IoT device, camera, small microcontrollers. Then if you are considering like 50% of the data set, so meaning they're training the entire 50% of the data set, we are considering things like satellites, cell phones, tablets, things that have a little bit more of computational resource. Then when you are considering 100% of the data, you're considering things that have high computational resource. So for instance, your own laptop or even a server itself. And basically what we realized that, yeah, indeed, when you're considering an entire supervised learning environment, the cost of labeling typically dominates in the entire training set. So for instance, if you consider the two on the right, you see here that the area that I have highlighted is regarding the labeling, and basically what it represents that labeling takes much more energy than actually training itself. Now, when you go to the other side, you realize that the accuracy, the performance that you reach when you're not considering labels, it's much smaller than the actually labeling area. And then there is this area in the middle, which basically represents an area that you reach high accuracies, but also consume little amount of energy for labeling. And this is the area of the semi-supervised contrastive learning methods. So what I'm trying to sell here is that there is a trade-off that we can build or we can observe in using a partial labeling information. So if you want to have further discussion on this, please look for this poster. And again, September the 2nd in IEEE Leap Special Session. I hope to meet you there and see you soon.